Okay, in this lesson, we're going to use our single payment compound formulas. We've already showed you in class on Tuesday how to develop these formulas, so we're not going to spend any time doing that. You can read the lecture notes or the book for the derivation of these formulas. So, basically, we're going to use these formulas to calculate future and present amounts. So, these are called single payment interest factors. Okay, the reason they're called single payment is because we are moving single values of money, one chunk of money, one chunk of change, lump sum payment. We are just moving one thing. Okay, here remember to review our notation. Little I is interest rate per interest period. N is the number of interest periods. P is the present sum of money. For right now, we're going to say that that is time equal to 0. That will change in the future. But right for today, it's going to be time is equal to 0. And F is the future sum of money. So we went through in class and we found out that any future amount of money, where's my pen here? Oh, there it is equal to the present amount times 1 plus the interest rate per period raised to the number of periods. And remember, we did that problem with annually, compounded, semi-annually, quarterly, and monthly. That's our formula. Okay? So let's just review. So here's our formula. F is equal to P times 1 plus I to the N. Now, we could remember that formula. Okay? I know that you guys could easily memorize that formula. But just for take a second, look in the front of your book, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 different formulas. I don't want you to have to remember all 16 formulas. So what we're going to do is I'm going to give you a shortcut. Okay? And a shortcut is just going to be called functional notation. This is a different way of writing the problem. Okay? So in this problem, listen to what I'm saying. I'm finding a future is equal to my present value times 1 plus I to the n. All I'm going to do right now is I'm going to change my pen color. I'm going to take this part of that, and I don't want to memorize that. So what I'm going to say is the future amount is equal to the present amount times, okay, instead of saying 1 plus I to the end, I'm going to say find a future given a present. Because that's what I said. What is the future? The future amount is equal to the present. I know the present amount. So it's just like in an equation, right? Whatever you want to find over what you have. Find a future given a present, add an interest rate for a number of periods. So I'm just replacing this piece right here that I circled with this functional notation. And basically what that is if you look in the back of your book, in Appendix C, okay, what they have done is they have taken the 1 plus I to the n for several interest periods and did all the calcs for you. All right, so we'll look at 1%, okay? Page 603, 1%, okay? I go down single payment, find a future given a present. It's the very second column from the left. I look at my number of periods and I look at the number, and that gives me the math. It does the math for me. So basically this thing here, this functional notation, is just going to do the math for you. You don't have to memorize equations or anything. And now a lot of people get all confused about, oh, how do I remember this over this? Well, think of it as functional. It has to be functionally, dimensionally correct, right? F is equal to P times F over P. Well, that makes sense. The p's cancel if you multiplied, and you would have f equals f. If you flipped it, if you said f is equal to p times p over f, you're going to get f is equal to p squared over f. That doesn't make any sense, right? So that's my way of remembering. Or just say, I want to find a future given a present. So here's how we're going to do these problems. Whenever you see one of these problems, the first thing you do is you draw a cash flow. Then you write down the givens on the diagram. You show what you want to find on the diagram. So that's all of our stuff. Interpret, plan, execute. All of our interpretation is done on the cash flow diagram. Draw the diagram, what do I have, what I want to find, figure out what you're going to do, and then execute it. So let's go do this example, okay? A firm borrows $10,000 for 8 years at 10% compounded annually. Oh, that's an easy one, right? Super easy, it's compounded annually. How much money must the firm repay in a lump sum, one payment, after the 8th year? So our interpret, right? We're going to write down our givens. Given, draw a cash flow. We know that the firm is going to get $10,000. That's our present amount in year 0. And we're going to do 8 years. 1, 2, 3, 4, 5, 6, 7, 8. N equals 8. You could draw the 1 through 8. I don't usually do that. I don't know how much we need to pay. And I know that my interest rate is 10% per year. So I'm going to put years on here. So I know everything's kosher. Okay? Use the formula. F is equal to P times 1 plus I to the n. There's my plan. Here's my solution. I'm just going to plug and chug. F is equal to P, 10,000, times 1 plus 0.1 raised to the 8th. I get, I got to pay a fair chunk back, 21,436. There's my future. Box in my answer. All is good. Okay. Next question says same problem, use functional notation. So in this second part, I'm going to go up here and grab a different color pen. My plan, instead of using the formula, I'm going to use the function. Future is equal to present. Find a future given a present. Add an interest rate for an n. Well, I'm going to plug and chug. 10,000 times find an f given a p at, let me see if I can go down here a little bit. Hold on. It's not going to let me go down. Okay, I'm going to run out of room. It's okay, I'll write small. 8%. Oh, sorry, 10%. Cross that out. 10% for 8 years. Okay, I go to the back of the book. Appendix C. I look for 10%. I'm flipping through it right now. It is on page 618. I look in the left-hand column. I know that n is 8. I go down to n is 8. Second little division in the middle. I slide my finger over. I want to find an f given a p. F given p is 2.144. So this value, where's my pen? I gotta find my pen. There it is. So this value, I draw a line through there and go 2.144. 10,000 to 2.144 is 21,440 is my future. Close enough. Same answer. No math. You're probably like, math's okay. It's just 1 plus 1 to the 8th. Well, if you look in the front cover of your book, look at those equations towards the bottom. Not so much. I think we may want to be using these tables. And on the FE, that's what we get are these tables. Okay, so I will stop for now.